Hello, my name is Samuel Otto. I'm an electrical engineering major at UW-Platteville, enrolled in the course EE 4360 Intelligent Controls. This is my demonstration of Lab 5 fuzzy tracking while avoiding obstacles. My selected scenario for Lab 5 is overhead deer tracking assistance. So in this simulation, there's an orange agent that it represents a deer hunter who is wearing orange. There is a brown target representing a deer that the hunter is trying to track. And the observer, which does not appear in the simulation, is assumed to be an overhead drone, giving us the footage seen in the simulation. The simulation includes two types of obstacles to avoid. The first being several black obstacles, which are bears or predators. And then there are stationary green obstacles representing trees. Now for a description of the fuzzy model and tracking strategy. The fuzzy model is composed of two input variables: the distance between the agent and the target, or the agent and a obstacle, as well as the angles between them. The distance is made up of 5 trapezoidal sets ranging from 0 to 71. The angle is made up of 8 trapezoidal sets ranging from 0 to 400. These, with a set of fuzzy rules, outputs 5 set magnitudes to move the agent away from a obstacle or toward a target, um, as well as the angle as in 8 set directions ranging from 0 to 315 degrees. The way this works is both the distance and angle between the agent and the target and the agent and an obstacle are calculated and added together via vector addition. There's a threshold of 10 position units between the agent and an obstacle before it begins adding to the vector that the agent is called to move to track the target. This is just a quick demonstration of the agent tracking the target in a maze. The tracking can be observed where it avoids going through points in the maze or the green spots, these representing trees. The agent is orange, representing a deer hunter, and brown is representing a deer. As you can see, it slowly tracks towards the deer, avoiding trees on its way there. This is the first iteration of testing of the agent tracking the target while also avoiding the black obstacles. These obstacles represent predators or black bears. As the tracking happens, you can notice that as it gets closer and closer to the target, it begins moving away from the target. But this is caused as the one obstacle nearest to the target moves closer towards the target, making the agent experience a repulsive force rather than an attractive force. This is the second iteration of testing of the agent tracking the target while avoiding the obstacles. As you can see in the bottom left corner, this iteration included the time to target and the number of close calls. This test resulted in a time to target of 3.1 seconds and 1 close call, meaning that the agent came within 5 position units of one of the obstacles that should be avoided. This is the third and final iteration of testing, where you can see the agent is properly tracking the target and avoiding the obstacles. Again, as in the first avoidance iteration, the agent moves away from the target towards the end because of the position of the obstacles and does not properly reach the target until the obstacles are far enough away. In this iteration, the time to target was 3.2 seconds and the number of close calls was 0.